This next section poses some serious difficulties just about every year. I have a section here that lots of people struggle with and do year after year. So you're going to have to do your best to stop, ask questions when we get going through it so that you understand what it is that we're doing. To begin with, we are talking about exponents and roots of a variety of numbers, rational and irrational, meaning a rational root would be the square root of 64, which would be 8. An irrational root would be any square root that is not a perfect square. Okay? The same with cube roots. And then we're going to look at the fourth and fifth roots of certain numbers. What has to happen for you to be really successful at this is to really understand or remember your first set of cube roots, square roots, and then even to the fourth roots and stuff like that. So just listing off your square root, your perfect squares. Let me do that again. Your perfect squares. So what are your first set of perfect squares? Give me a perfect square.
1 squared is 1.
1 squared is 1.
2 squared is 4.
4.
3 squared is 9.
9.
4 squared is 16.
16, 25, 36, right? 49, okay, 64, 81. You want to know the first 12. Know that 12 squared is 144. You want to know all the way up to there because it's going to make your life a lot easier when we work the reverse. When I say to you, okay, what's the square root of 81? You need to know that it's 9 and quicker. Because otherwise you're going to fight with it. And if you have to use your calculator a lot in this, it's going to take you too much time it takes to do stuff. Okay, so the first thing that we are going to do today is looking at exponent laws, which I suspect that there was some done with this. Okay, so to begin with, can anybody simplify that and tell me what I get? When I multiply two values together that have the same base. Okay, first of all, this is the exponent, and this is what we call the base. So when they have the same base, meaning I have 3 as my base value, what do I do with the exponents here?
Don't you add the exponents?
You add the exponents?
Yeah, I think so. Maybe subtract.
You think so? Okay, so what do you think the value, what do you think this is then?
3 to the power of 6.
Yeah. Okay, do we agree or disagree with that? How many of us don't have a clue? Okay, fair enough. How many 3's do I have here? 2, right? And then I got 4 more here. So how many do I have total?
6.
So it's 3 to the 6. So that's right. When you multiply two values together with the same base, you add their exponents together. Okay? What happens, and I'm going to come back to this. So, I'm going to use a or x. So what I have here is this. A to the m times a to the n. Okay? So the exponent law says that when I take two values with the same base, I add the exponents together. So that gives me a to the m plus n. Okay? But the bases have to be the same in order for you to do this. All right? What do you think happens when I divide? What do I do with the exponents? Subtract them. Okay. So let's find out if that's correct. Let's take 3 to the 5th divided by 3 squared. Okay? How many 3's are on top? 5 on top. How many on the bottom? 2. So 3 divided by 3 is 1. 3 divided by 3 is 1. What does that leave me with on top? 3 to the power of 3. So it sounds like you're probably correct. when I take two values in which I have the same base, different exponents, when I'm dividing them, I actually subtract the exponents. A to the n minus. So far, are we following this? Okay, so there's rules 1 and 2 so far. What we call the exponent laws. So laws 1 and 2. All right. Questions so far?
For the
Go ahead.
like for the dividing the threes, you just divide them by 1,
Divide them by 1? Nope.
or just they just cancel out because they're the same top and bottom.
What happens when I divide any number by itself?
1,
You sure?
3, like 3 divided by 3.
Yeah.
1,
1. 4 divided by 4.
1,
5 divided by 5. So when I divide them, it just becomes 1, correct? I don't have to write 1 in there because I'm still multiplying. So yes, that's the answer to your question. Okay? All right. Next one. Oh, I did that wrong. What does that give me? 3 squared to the power of 3. What do you think I do with the exponents here?
Times them together.
Times the exponents together? Yeah? So what would this be?
3 to the power of 6.
6.
Okay? All right. What is 3 squared to the power of 3?
729.
But just when I want to write it out, it's actually 3 squared times 3 squared times 3 squared, right? Is that not 3 squared to the power of 3?
Yeah.
Take that value squared, I times it by the next value, and then, so how many 3's do I have in this set of brackets?
2.
And how many here?
2.
And how many here? So how many is there total? 6. So, law number 3. A to the m to the a to the m to the power of n. I multiply the exponents together, and I get a m times n. So far, so good. Okay. There's 3 laws. So this one's called the power of a power. Okay. These ones I don't necessarily feel I need to write them out, but I'm gonna do it like this anyways. Actually, this is probably a good one to do. AB, so 2 different values, AB squared. What do I do with that exponent?
Square the answer.
Square the answer?
A.
Yeah. Yeah, you would, right? But what do I do with the exponent through here right now? What do if I was to expand this, what would it write out to be?
Oh, A squared. A squared plus B squared.
Just a squared times b squared, right? Write this down. A squared times b squared. I transfer that through the brackets. Now, what is a times b squared? Well, that's like saying a times b, a times b, right? What's a times a?
B squared.
A squared. And b times b? B squared. So that's how come it becomes a squared, b squared. So far, so good. The same thing occurs here. A over b squared is like saying a squared over b squared. Okay? That exponent goes for both of them. So far, so good? All right. Now, these are the pretty standard ones I've given you so far. There's two other majors. E to the 0. What is the value of any exponent to the 0? 1. It's not nothing. It's not nothing. It's important that we know that. Anytime you have an exponent 0, your answer is 1. All right, let me show you why that is. We had one rule already. What do I do with the exponents when I'm dividing? I subtract them. So this would give me 3 to the power of 0. Would you agree with me? Yeah? That's 27. That's also 27. What's 27 divided by 27? 1. Does that make sense? Why? 3 to the power of 0 is equal to 1. So the rule is any exponent 0, the value is always going to equal 1. Okay? There's another 2 that these ones are harder to understand, so we're going to try the best we can here. A to the power of negative m. Okay? A to the power of negative m. If I would like to write this such that I do not have an exponent with a negative value, I can take that value, I can rewrite it on the bottom of a fraction, and it becomes positive. So this becomes 1 over a to the m. Okay? So to rewrite any value that is a negative, you either move it to the bottom of the line or to the top of the line and make it positive, depending on what it is. Okay? So I'm going to give you a couple more examples so you can kind of see what's going on here. So if I have this, one over 2 to the negative 5, I can rewrite that as 2 to the 5th. Okay? If I have 3 to the negative 1, to write it as a positive, it becomes 1 over 3 to the 1. I'm going to switch it, but that's a biggie. It's a biggie because when you're working with them, the majority of the answers they ask you, they want positive exponents for it. Okay, so you have to follow through on that. So if I had something like this now, what do I do with my exponents? I subtract them. So what does that give me? 3 to the power of? Negative 2. Right? Follow me so far? That's absolutely correct. Okay? But if I expand this out and I divide it, you're going to see what happens here. So on top I have 3 times 3. Agreed? And on the bottom I have 3 times 3 times 3 times 3. Good so far? So what is 3 to the negative 2 written with a positive value of 3? That becomes 1 up here because I cancel them. And where do those 3 squareds go? 3 times 3 goes on the bottom and becomes 1 over 3 squared. That's why it works like that. Okay? All right, I'm going to introduce a couple of things here today. Just want to make sure, I want to see where we're at here first. Yes, I do. Okay. All right, how are we doing with these rules so far? So there's basically 5 or 6 laws right now. So when your bases are the same, you add the exponents. When your bases are the same and you're dividing, you subtract the exponents. When your bases are A to the m to the n, you multiply. So all of these you just have to work with till we get to know. Here's one that you don't know and you don't see very often. If I ask you this, what is the square root of 4? 2. You all agree it's 2? If I wanted to write that, and instead of the square root, I want to write it as an exponent. Anybody know how to do that? Say that again? Okay, sure. But I don't want the square root value. It's weird, eh? Can I know? Quite? No? No? Okay, so it's hard to ask this question and make it make sense. This is the newest thing for you. You have never seen this before, so this is new to you. The square root can be written as a fraction to the 1/2. Okay? Now, now that I know this, somebody just finished telling me that the square root of 4 was 2. You agree? Okay. Now we had some rules today. And when I have an exponent to an exponent or a power to a power, what do I do with those? I multiply them. What is 2 times 1/2? What is it? 2 times 1/2, Shay? 2 times 1 is? 2 times 1 is what? 2. 2 divided by 2 is? 1. That's why the square root of 4 is 2. Because when I change the square root value to an exponent, it becomes exponent 1/2. Okay? And then when I multiply it, 2 times 1/2 is 1. Alright so far? So if I ask you what the cube root of 8 is, anybody know what the cube root of 8 is? What am I asking you? Louder, Daylin? Nope. Not 8 divided by 3. No. What is the cube root of 8?
What number multiplied by 3 equals 8?
Not by 3.
Multiplied by 12. Yeah.
By itself 3 times gives me 8. Get off your calculators. Get off. I want them. Think about what I'm asking you here. What value do I multiply by itself 3 times gets me to 8? Your numbers are limited. Your options are limited, are they not? Because as soon as, well, what's 4 times 4? 16. That's a doozy of a question there. 4 times 4 is 16, so we're already over that. So it can't be 4.
2.
What is it?
2.
The answer is 2. The cube root of 8 is 2. Okay, now, think about what I just did here. With doing this exact same process right here. Now, I'm just showing you the very basics so you can get it. All right? I expect you just to write 2 as your answer, but I don't expect you to do all of this work that I'm doing right now. I just want you to see it so you understand what, when it gets a little more complicated, we have to do. So, I just finished saying that 2 cubed is 8. You agree with me? Now? Right? 2 times 2 is 4. 4 times 2 is 8. Okay? What do I write this as then? The cube root as an exponent is what? Well, if the square root was 1/2, what do you think the cube root is? The third. So I write this like this. 2 cubed to the 1/3. Right? What's 3 times a third? What is it? 1. 2 to the power of 1. Okay? There's a lot of fraction work in this, so that's partly why it's not very well liked. There's a lot of happening. Okay? So far, so good? So now let's go back to 4.1 and let's see what they're doing there. You have the rules. You don't need the rules in 4.1, but you need to know how to break down. So what we're looking at today, and all you're looking at today, is square root and cube root. No more than that for right now. We will get into the fourth and fifth roots, but not right now. But this is a section that comes back in grade 11. You don't do it in grade 12 at all. But this section comes back in grade 11. So you need to do the best you can on this and hammer it out. Because if you get, it gets a lot harder in grade 11. And they'll tell you, this was the hardest unit that they did in grade 10. They really struggled with it. And so then when we get it in grade 11, they struggle with it again. So the better you can do now, the easier you're paving your road for you in grade 11. All right. We know now what these two symbols mean. This and this. So the square root of the number, what number do I multiply it by itself to get that number? So what is the square root of 9? What is the square root of 16? Square root of 25? Square root of 100? Square root of 121? Square root of 144? Okay, so that you understand what that symbol means now. Okay, I want you to work with me for a minute here. What is the cube root of 8?
64.
64? Cube root of 8?
Oh, 2.
I just did it. What is the cube root of 27?
3.
3. What is the cube root of 64? So better.
4.
Okay. Cube root of 125. 3, 4, 5. Right? You see how this is working now? Okay? So the cube root is what number do I multiply by itself to get you there? You need to know those first 5. All right? Just by heart. Because we get into some complicated things and you need to know those basic ones to make your life fairly straightforward. Okay? Everybody follow me so far? Okay. Now, another thing that we do, like, for example, they do allow you in this section to use your calculator a little bit. They want you to break it down, but they do let you use your calculator a little bit. So, does anybody know how to punch that into their calculator? Can you do it? Can you find me the cube root of 64 on your calculator? Okay. Does everybody know how to do it? Because it's a different button that you haven't used yet. I want to make sure you know how to use it. Anybody not know how to use their calculator? You good? Anybody else not know how to use the calculator for this? You have it? No, you don't. No. So, 3. Okay, does everybody know how to use it?
Second function, 3, 64.
All right, here's my next question to you then.
Got it? Because it's just like.
You found out how to do it on your calculator with the cube root. Everybody found that? Okay. I said to you earlier today that this was 64 to the 1/3. I want you to punch that into your calculator now. Not the cube root. I want to find 64 to the exponent 1/3. Which should give me what? 4. So if you cannot do that, then I want to look at it. So I'm asking you to find the exponent or the value of 64 to the exponent 1/3. You know what to do?
Oh, wait, I might.
Okay.
Yeah, I got 21. Yeah, I got 21. Yeah.
You got 21?
Yeah.
Yeah, I have 21.
You got to pick that. Yeah. Oh, yeah, I got 21.
I put brackets around.
I need to see. Leave it on there.
I get it.
Let's see what you punched in.
Oh, yeah. Yeah, that's
And you missed your button too. The exponent button.
No, I figured.
Okay, so if you got 21.3 repeating, what you punched into your calculator was 64 times a third.
Yeah.
Alright, that's exactly what you got. Okay, so that's not what I want. I want 64 to the power of 1/3. Now,
Oh, I know.
to do that, most of you, I don't know all of the calculators, but most of you, yours is a half, you know yours, okay? Most of you will have a y to the x or an a to the b or some button on there. It's, let me just see, yeah, what is it? It's not here. What?
I can't see your picture.
Okay, so lots of you will have this. Y to the x button, okay? Then you needed to do this. Like that. Okay, so now punch it into your calculator, make sure you get 4. Okay, so that's one of the functions that you are actually being asked to use on your calculator, is that guy right there too. So you have the cube root function. I would always use the cube root function, don't get me wrong. But I want you to understand that if you have an exponent of a fraction, that's how you need to punch it into your calculator if it's something that's being asked of you. Did anybody not get 4? Okay. Did you get it? Okay. Morgan, did you get it?
That one, like the copying there?
Yeah.
So not really.
Not really. So it's not really. 64. Y to the x. Do a little half, okay?
I don't have it. Second function or not?
Hold on. That's what I want. Follow what I did there? 64 and this y to the x button.
So you put that one down there? Oh yeah, for the quiz. Oh, I see.
I cracked my neck when I did that. Scissors.
Is exponent. Anybody else? Make sure you get. Anybody else? Not get that 4? Okay? Because you're gonna need a lot more complicated questions, so I need you to make sure that you know how to do that. Alright? So far so good? Okay. So what you've done there is you found the cube root of 64. Which is 4, because when I take 4 times 4 times 4, I'll get 64. Alright? Now, you need to be able to use your calculator to break down much larger numbers that are perfect squares. But basically all 4.1 is just using your calculator. But I do want to show you one last aspect of it. This is the part that really, really confuses everybody. And this is where they begin to struggle. And that is this. If I have the square root of 64a squared. What is the square root of 64a squared? Not sure? Do I want to have a guess? Brandon? 8a? Pretty good guess. What is the square root of 64? 8. So then what's the next part of it that I have to solve for? The square root of a squared. Which is what? Okay. What number do I multiply by itself? Or what value do I multiply by itself to get a squared? The answer is 8. So the square root of 64a squared is? Okay. So let's make sense of that a little bit easier. This is what you want to see right here. What is the square root of a squared? That's the part that confuses everybody, right? We should be able to get the square root of 64, no problem. Even with your calculator, you should be able to get it quite quickly, right? But what is the square root of a squared? Well, what did I say this square root was as an exponent?
Oh, I just counted it up.
What is it? What is the square root written as an exponent?
2.
What is it, Dylan? It's a half. So I have a squared to the 1/2. Right? What is 2 times a half? 1. So it gives me a. The square root of a squared is just a. Well, how do I get a squared? I take a and I times it by another a. So that's simple. Okay? All right? I'm just looking at your questions. Okay. So I'll give you one more because I want you to see it. What is the cube root of 125y cubed? Well, what's the cube root of 125? 5. What's the cube root of y cubed? Okay? So today's work that you need to be doing on 4.1, a good majority of it is calculator work, but a good portion of that calculator work should be done up here. All right? If your values are greater than 144, then you might need your calculator. But for right now, you should know the square roots of all the numbers up to 144. Okay? After that point, then sure, go ahead and use your calculator. Any questions today about this so far? Everybody knows how to use that calculator now? Find cube roots and cube values. All right. You have the remainder today to work on 4.1 and 4.2. Are any of you missing tomorrow or the next day? Some of you guys are gone tomorrow. Okay. You can expect, and 4.3 is the carry on of this. You can expect to be into 4.3 for Thursday. Okay. Okay. So you know what your work is. Yep. Everybody understand that? We will be at the end of 4.3 by the end of this week. Okay? So those of you that are missing any school in the next 3 days after today, you know what you have. Okay?
Wait, so will we be doing 4.3 on Thursday or having?
We will be at the end of 4.3 by the end of this week. So Monday you'll be doing 4.4. Okay? We want to wrap up chapter 4 by spring break. That way there's nothing lingering over. Okay? All right, you got the rest of today to work.